Hellier College Math students. We're going to continue talking scale factor in this video. Now we have a very simple equation here that says the scale factor in a plan is equal to any length on the image divided by the corresponding length on the original. So to determine the scale factor, there might be, say, say a map with a road on it. So we would measure the length of the road on the map, and then if we divided that by the real life length of the road, we'd get the scale factor for the plan that we're looking at. Now let's skip ahead to this example here. We need to determine the scale factor for these two situations. On the left here we have a trapezoid which has been enlarged, and on the right we have a pentagon which has been shrunk. So we want to know by what scale factor have these two transformations been done by. So you might want to try this first. Once again, we take some measurements, and I'm going to measure this length, or this one here, and compare it to this one here. And for the pentagon situation, we'll measure, well, they're all the same length, so it doesn't matter, but I'll measure these two and determine the scale factor that way. So you might want to pause the video and take some measurements in millimeters there, then I'll show you what I thought they were. Okay, so I thought that here for this trapezoid we had 20 mil here. It's a bit fuzzy looking, but I think we get the idea. I'll have another go at it. So 20 millimeters. And here 30 millimeters. So if we divide the new one, so here we've got the original on the left, and we've got the image on the right. So it's going to be image divided by original is our basic idea. So 30 over 20. Now that gives us 1.5. So here our scale for enlargement is 1 to 1.5. So everything has been enlarged by 1.5 here. We could also say this is 2 to 3 if we wanted to have integer values. So by integer I mean whole number values. Here we've got a decimal 1.5, that's not an integer. Okay, but 1 to 1.5 is fine. Right, now on the pentagon example, clearly we've got some shrinking down occurring. So I've measured this at 20 millimeters, and here 10 millimeters. So the image is at 10, and we divide that by 20 for the original, and we get a half, 0.5. So in this case, we've got a 1 to 0.5 scale. Or we could express this a little bit differently. We could say 2 to 1. So anything that's, what we're doing, 1 is a half of 2, so we're reducing the size by half. Okay, so there are our two scales. These answers here are fine, if you got those. So you might want to pause the video and try these examples about this photograph here, and then I'll put some answers down for these ones. Okay, so this is relatively simple, this next part. we're using a scale factor of 2.5, so it's being enlarged. Okay, so if we multiply both of those measurements, the length and the width, by 2.5, we'll get that this is now 15 centimetres by 10 centimetres. That's the size of the enlargement. I better put those units in there. So gone from being a 6 by 4 to a 15 by 10 size. Okay, now that actually answers that one down there, doesn't it? That's for that one. Okay, so a ladder in the enlargement, it was 3.1 centimetres on the original. So if we multiply that by the scale factor that's used, 2.5, on the enlargement, it'll be 7.75 centimetres. So in this case, we're going from the real measurement, the original measurement, to the enlargement, so we're multiplying. Now here, if we want to go back the other way, of course we'll divide. So there's a pot plant in the enlargement, which is 4.2 centimetres. We'll divide that by the scale, and that tells us that the pot plant in the original photograph was 1.68 centimetres in height. Okay, look in the description for the video for the questions that you can try on this topic.